last lecture we started doing spherical mirrors. Okay, we looked at the important ray diagrams, laws of reflection, image formation, and all that. Okay, this lecture let's try to see how all those terms are related. Okay, that is the mirror formula. We are going to derive one mirror formula. Okay, let's start doing that mirror formula. Okay, now let's define few terms here. Let's say that I have this mirror. Okay. This is pole of the mirror. This is, let's say, this is my focus. This is focus. This will be center. Center here. Okay. Let's say that my object is kept here at some distance here. This is our object AB. Object AB. Now where will be its image? We can find it using the ray diagram. Okay. So let's take one light ray here. After reflection, it passes through focus. Okay. Now if I take one other light ray, let's say let me take one light ray here passing through center. Now what will happen? What will happen to this light? Okay. This light will retrace. It will retrace itself. Okay. So because it is an incident normally, it is going to retrace. So at this point, both reflected rays are meeting. This will become image of point B. Okay, that is B dash. Image of point A will be directly above this here on the principal axis. Image of A is going to be on the principal axis. This becomes A dash, let's say. Okay. Now, the radius of this mirror, okay, is R. This is radius of the mirror, and F is the focal length. F is focal length. Okay. Now, object is kept at some distance from the mirror. Okay, this distance of object from this pole is written as U. It is written as U. Okay, the image is formed at some distance from the pole. This is V. Okay, so you have to note down U is object distance. This is my object. V is image distance, and this is here my focal length. This is a focal length from pole to focus. Okay, focal length. Now, how these terms are related? Now, there is one other term, that is, this is AB object. Its height is HO, height of object, and this is height of image HI. Okay. Now, how these all the terms are related? So, the first relation is F is equal to R by 2, half of radius. Focal length is half of radius. Okay, second relation is 1 over V plus 1 over U is equal to 1 over F. This will be relation between object distance, image distance, and focus. We are going to derive this relation. Okay, I'm just writing it here at one place because we are going to do problems using these formulas, these relations. And third one is we define magnification. Okay, lateral magnification. M or only magnification. When I say only magnification, by that what we mean is lateral magnification. And what is the meaning of lateral? There are two terms. One is longitudinal and the other one is lateral. Longitudinal will be along this axis, and lateral will be normal to this axis, 90 degree. Okay, so if an object is kept lateral to the principal axis, that means normal to the principal axis. Okay, for that, how do we define magnification? It is defined as M magnification is equal to height of image, okay, divided by height of object. Okay, so this M is equal to height of image over height of object, and this turns out to be equal to minus of V over U. Minus of V over U. Okay, makes sense? Now, this is mirror formula. This is how the different terms are related. Now, there is one sign convention. Okay, the object can be kept here, on the left of it. The image can form anywhere. To the left of pole, to the right of pole. Object is above principal axis. Image can be anywhere. It can be above principal axis. It can be below principal axis. Okay. So we have developed a sign convention, a standard sign convention, and that sign convention is common to all the optical system. Okay. Whether it is mirror or it is lens or it is a combination of lenses and mirrors or whatever it is. Okay. So we are going to write, we are going to understand one sign convention. That's it. Only one sign convention that will be common to every system. Okay. Then here it is. Sign convention. Sign convention. Okay. First of all, distances along principal axis are measured from pole. Okay. First thing, okay, all the distances, whether it is a focal length or it is a object distance or the image distance, everything is measured from pole along the principal axis. Now, this is the first convention. Second, okay, distances along principal axis. Distances are along principal axis, okay, is taken to be positive, okay, in direction of incident rays. And negative in opposite direction. This is the convention that is the most standard convention. Okay, and we are going to follow this standard convention in every system that we are going to study, whether it is mirror or lenses or combination of mirrors and lenses, combination of lenses. Okay, any optical system, every optical system, we are going to follow this convention only. First convention, along the principal axis, whatever I measure, all the distances I will measure from pole, first of all. Okay, then distance along principal axis is taken to be positive in direction of incident rays. Now, what does that mean? What does that mean? This is my object. These are the incident rays. Incident rays are going towards right. Incident rays are going towards the right. Okay. So all the distances along principal axis to the right of pole, will be taken as positive, and to the left of pole will be taken as negative. Try to understand this very, very clearly. Anyway, we are going to do many problems, and we are going to use the same sign convention. Okay, you will become comfortable. You will become well versed in it. So, this is my object. Incident rays are going towards right. So, distances to the right of pole will be positive, to the left will be negative. Okay. For example, if I ask you what will be object distance? What will be object distance in this case? This is my object distance AP. Now this is to the left of this pole. Incident rays are going towards right. I have to measure all the distances from pole this object distance is to the left of pole, it will be negative. It will be minus of AP. That means if this is 10 centimeter, then U will be minus 10 centimeter. So in this formula, when I am going to use this formula, I will write U as minus 10. Okay. V. Similarly, U, V and F, object, image, focus, all of them are to the left of pole. To the left of pole it is negative. Why it is negative? Because incident rays are going towards the right. So distances to the right of pole will become negative. To the left will become positive. To the left it becomes negative. Now so this will be equal to A dash minus of, okay, let me write it like this, maybe it makes more sense. This is PA, this becomes minus of PA dash. Okay, what will be focal length? Focal length, it will be equal to minus of PF, minus of PF. And what will be radius? Minus of PC. And this becomes radius. Radius will be negative. So for this mirror, for this case, object distance, image distance, focal length, radius, everything is going to be negative. So I will write negative values when using this formula, using this relation. Okay, do you understand this? Now, third, distances above principal axis are positive and below it are negative. Okay. Distances above the principal axis. This is my principal axis. Okay, I have this distance here, AB. This is height of object. So if I have to write height of object in this expression, if I want to write height of object, so I will write plus AB. It will equal to plus AB. So if AB is 2 centimeter, I will write height of object plus 2 centimeters. Height of image. Now this distance is below principal axis. It becomes negative. Okay. So height of image, it becomes minus of A dash B dash. Okay. Note down very clearly the sign convention that we are going to use. Now let's derive these two relations. Let's derive. Okay. Now this is my incident ray. This ray is parallel to principal axis. Let's say that it hits the mirror here. Okay. And if I drop a perpendicular here, let's say this is M and this is N. Okay. Understood? Let's say that this angle here is theta 1. Let's say it is theta 1. Then angle here, this also will be theta 1. Theta 1 here. Okay. Now, if this is theta 2, then this also is theta 2. Okay. Understood? Okay. All right. Now, for taking or assuming paraxial rays, that means this light ray is very close to the principal axis. That means my object is very short, okay, a very small height, very small length here. This ray is close to the principal axis, okay. So I can say that, okay, this FP or PF is approximately equal to, okay, NF. Can we do that? What do you think? Now, if this light is very close to this axis here, okay, so this point is going to be very close here, right here, okay. So when I drop this perpendicular, okay, these two distances are going to be approximately same. Okay, makes sense? Now, if I write tan theta 1, what will be tan theta 1 here? will it be equal to AB over AC? It will be AB over AC. Okay, and this is also going to be equal to, in this triangle A dash B dash, A dash B dash, A dash B dash over A dash C, A dash C. What do you think? Does that make sense? Does that make sense? Okay, and this I can write as, or let me write it like this, or let me write tan theta 2, tan theta 2, tan theta 2. This is theta 2. What will be tan theta 2? This is mn over mn. This is mn over nf is going to be equal to this. Okay, A dash B dash over A dash f. What we are doing? We are trying to derive this mirror formula. Okay, makes sense? Note it down. I'm going to clean it. Okay, I'm going to clean now. Okay, now mn will be equal to AB. Okay, so this, because I can write it as AB over NF, I can write as PF. Okay, is equal to A dash B dash over A dash C. Okay, please follow this. From here I can write AB over A dash B dash is equal to AC over A dash C, and here I can write AB over A dash B dash is equal to PF over A dash C. Okay, is everything right? A dash F. Okay, this is AB over Fn. Fn, I am writing it as PF. Okay, so PF over A dash C. No, it is not A dash C, it is A dash F. It is A dash F here, not C. Okay, now let's combine these two. Okay, if I combine these two, okay, what I have is actually AC over A dash C is equal to PF over A dash F. Now AC, what is AC? This thing, AC. Can I write it as PA minus, okay, PA minus PC over A dash C. A dash C, this thing here, is equal to PC minus PA dash. Okay, is equal to PF over A dash F. A dash F will be equal to PA dash minus PF. Okay, where we are heading towards. Okay, you will see soon we are going to get this result. Okay, this is derivation. First time it may appear little difficult, but when you do it on your own, it will become very easy. Just remember how we are doing it. Tan theta 1 from these two triangles, tan theta 2 from these two triangles. This is going to be equal to this, and this is going to be equal to this FP. Okay, now PC, PA, what is PA? PA is minus U. U is minus PA, so PA becomes minus U, minus PC. What is PC? PC is minus R. I can write it as minus 2F. Makes sense? Divided by PC is minus 2F minus PA dash here is minus V, minus V is equal to minus F here over PA dash is minus V minus F. Okay, so here I have what I have here, 2F minus U over V minus 2F is equal to minus F here, okay, so minus F here over F minus V. Okay, let's see where we are heading towards. Okay, soon we are going to get the answer. This is going to be equal to 2F square minus UF minus 2FV plus UV is going to be equal to minus VF plus 2F square. This gets cancelled. Okay. What I have is okay. UF, if I take it on the other side, if I take both on the other side, okay, it becomes UF plus VF is equal to UV. Now divide all of them by UVF. What do I get? This is 1 over V plus 1 over U is equal to 1 over F. Okay? Now, we derived it. At the same time, let me tell you that, this is not the only way to derive it. You can explore your own ways. You can find your own ways of doing the same thing. It is just one way of doing it. Okay? So this relation we derived. Here. Now what about magnification? How do I get this? Minus V over U. Okay, it should also not be difficult. Okay, I'm going to clean all this. We derived it already. Okay, now I want to find relation between height of object, height of image, and I want to find derive this relation minus V over U. How do I get it? Okay, I can make use of which one? Okay, I think this will be the best thing to do. If I take one other light ray here, a light ray which hits the pole, okay, this light ray here, after reflection it is going to meet here. Okay, after reflection, of course, it is going to meet here. Okay, you understand? Now this angle here and this angle here, both are going to be same. This is theta 3, this will be theta 3. Okay, I am going to write tan theta 3. Tan theta 3 is going to be equal to AB over PA is going to be equal to A dash B dash over PA dash. Okay, now what does it give me? AB. What is AB? AB is H. Okay, so plus height of object here. PA is minus U is equal to A dash B dash. A dash B dash is minus HI, minus height of image, over, okay, PA dash from here, minus V. What do I get? Magnification is equal to height of object over height of image over height of object. Okay, and this is equal to, from this relation, it is going to be equal to minus of V over Q. Okay, that's it. Note down everything from here. Note down everything from here. And now we are going to solve problems. Okay, let's look at few problems. Okay, first question is like this. I have E, F and C. Okay, now question is, at what distance from pole the reflected light meets principal axis. Okay, this is the first question itself is a kind of difficult question. Okay, chances are you may not have done this problem earlier. We are starting, this is our first problem. Okay, and now the second problem. Okay, so we are starting with a difficult problem. Okay, then everything will become easy. This is C, this is F. Okay, so I have these two problems. This is my angle of incidence. This is theta. What do you think? Both are parallel lines, parallel light rays, parallel to principal axis. After reflection, they are going to meet principal axis. At what distance from pole they will meet principal axis? Okay, that means, let's say that this is the reflected light. Okay, it meets here. Okay, so I want to find this distance. What will be this distance? Similarly here also. Okay, it is going to meet somewhere. What will be this distance? Okay, what will be this distance? The focal length, the radius of this mirror is R, focal length is F. Same here, radius is R, focal length is F. What do you think? Do we need to solve it? Is this not a standard case? The answer is we need to solve it. This is not a standard case. Okay, mind it. This is not a standard case. What is a standard case? The standard case is for paraxial rays. When the light rays are very close to principal axis, very close here. In that case, theta becomes very small. When theta is very small, only in that case it becomes a standard case. Then it is going to pass through focus. But that happens only when theta is very small, when the light ray is very close to principal axis. Here it is away from principal axis. It is not going to pass through focus. Understand this very clearly. Both light rays, they are not going to pass through focus. Okay, so answer is not going to be F. Okay, so if you are answering this, that answer is going to be F, then this is incorrect. How do I find it? Okay, let's see. Okay, now the first case. Let's look at the first case here. This is my first case. This is the incident ray, and this is my, okay, this is a 45 degree. That means, okay, let me do it like this. Here, let me take this as 45. This is my 45 degree. This is angle of incidence. This is my center. Focus is somewhere here. If this is 45, this is also going to be 45. Okay? Do you understand this? This also is going to be 45 because this line is parallel to principal axis. This is angle of incidence. What will be angle of reflection? It will be same. The other angle is also going to be 45. This angle is also 45. So 45 here, 45 here. That means this is 90 degree. This is 90 degree. Okay. Let's say that it intersects here at point O. Okay. So what will be OP? What will be OP? It will be equal to PC minus OC. Okay. What is PC? It is equal to R minus. What is OC? What is OC? It is equal to R. This thing is also R. Let's say this is M. M here and N here. Okay, let me write it as N. So NP is equal to PC minus NC. Okay. What will be NC? This whole thing is R. This also is radius. This is radius. This also is radius. So R cos 45. R cos 45. That becomes R minus R over root 2. This is the answer. This is answer to this question here. Of course, it is not equal to F. Clearly, it is not equal to F. Okay? There is no chance for that. Okay. So this distance here, NP, is equal to this value. This value here. Okay. Now let's look at the second case. Second case is like this, a general case. Second case is a general case. This is center. This is angle of incidence. It is theta. Angle of incidence is theta. So this angle is also going to be theta because these two lines are parallel. They are parallel. Now the light is going to be reflected in this direction somewhere like this here. That's how the light is going to be reflected. This is theta. This also is theta. Okay. This is somewhere F here. This is N and this is M, let's say. I want to find NP. NP. Okay, NP. NP is going to be equal to PC minus NC. PC minus NC. PC is equal to R. PC is equal to R. It is radius, okay? Minus NC. What is NC? Now this is going to be difficult. This is theta. This also is theta. Okay. Now if it becomes easy if I make use of some geometry, or before I do that, you should pause the video here and then try doing it yourself. Okay. I'm sure you will enjoy and learn a lot of things. If I drop, okay, I'm going to discuss now. Do not blame me. Okay. I'm going to become one spoiler here. So this is, if I drop a perpendicular here, okay, this thing here, these two angles are same. If I draw perpendicular, then this perpendicular is going to bisect it. Okay, so this becomes R by 2 here, this also becomes R by 2. Okay, then what will be this distance? Cn, this distance here is going to be equal to, what do you think? What do you think? Okay, I will write cos theta. Cos theta is going to be equal to R over 2 over Cn. Okay. Alright. So Cn is going to be equal to R over 2 cos theta. R over 2 cos theta. This is the answer. This is the answer. Okay. In terms of, okay, I can write it as like this, R, okay, 1 minus half cos theta. If I put theta as 45, I will get this answer again. Okay, now, if theta is very small, okay, that is paraxial range. Paraxial range. When theta is very small, what will be cos theta? Cos theta is approximately equal to 1. Then what will be NP? What it is going to be equal to? It is NP is going to be equal to, R 1 minus half, this is R by 2. Okay, and this point is known as focus. This point we define as focus. So F is equal to R by 2. Okay, so we define focus only for such cases, these cases here, only for paraxial rays. So only paraxial rays pass through focus, and in that case only focus will be equal to R by 2. Okay, do you understand this? Okay, let's do a few more problems. Okay, let's start with questions based on mirror formula. A point object is kept on principal axis. Okay, this is a principal axis of a concave mirror of radius. Okay, a point object is kept on principal axis of a concave mirror of radius, let's say 40 centimeter at distances first 10 centimeter, 30 centimeter, 60 centimeter from pole. Okay, all right. Locate image. Okay, locate image. Find nature of image. And draw corresponding ray diagrams. Okay. We are starting with this simple problem, very simple problem. Okay. The chances are you must already have done this kind of problem. Okay, or maybe this problem itself you may already have done. The purpose here is to learn how to apply sign convention and how to apply mirror formula. That is the purpose. Okay, and let's do one more problem. Okay. Repeat above for a convex mirror of same radius. Okay, let's see how to do that. Okay, we are going to learn how to use the sign convention and how to use the mirror formula. Okay, let's start with first case. Several things we are going to learn. Okay, first case here, radius is equal to 40 centimeter. What will be focal length? Okay, the magnitude will be equal to R by 2. This is going to be 20 centimeter. Okay, now this is my concave mirror. Pole. Okay, this is focus and this is center. Where is the object? Object is kept on principal axis at a distance of 10 centimeter from pole. Okay, my object is here. This is my object. My object is here. Okay. I will apply this formula 1 over V plus 1 over U is equal to 1 over F. Okay. Now 1 over V is equal to, okay, Or let me write it like this. Here it said 1 over V plus 1 over U is equal to 1 over F. Okay. 1 over V is equal to 1 over F minus 1 over U. Okay. Let me write it directly. We are doing the first case here. First case. 1 over V is equal to 1 over U, 1 over F. In this formula, I have to write every term with its proper sign. I do not know V. I do not know image distance. So I will just write V. This is my unknown. This is my unknown. I do not know what it is going to be. Whether it is going to be plus or minus. I have no idea. This is a variable. I want to find its value. I will keep it as it is. Okay, understand this. Very simple point, a small point. It causes confusion. Okay. Alright. I have to calculate this. I do not know what it is going to be. It can be positive, it can be negative. Okay. I will keep it as it is. 1 over F. What is 1 over F? Focal length, the magnitude is 20 centimeter. This is the magnitude. Okay. With sign convention, I have to write here with sign convention. Is it going to be plus 20 or minus 20? The object is kept here. The light rays will go towards right. Only those light rays will be reflected and they will form image. Image from a mirror forms because of reflection. Light will be reflected only if it hits the mirror. You see, light rays will go here also. They will go in all the directions. But only those light rays which go towards mirror, which hit the mirror, only they will be reflected and they will form an image. Understand this? Okay. So I have to consider only this light ray which is going towards the mirror. They are going towards right. That means distances to the right of pole becomes positive and to the left of pole becomes negative. Focus is to the left of pole. So focal length will be negative. I will write 1 over minus 20. Okay? Minus 1 over V is 1 over F minus 1 over U. What about U? Where is the object? This is my object. This also is kept to the left of pole. To the left of pole, it is negative. Okay? So here also I will write negative minus 10. Okay? What do I get? What I get is 1 minus 1 over 20 plus 1 over 10. This is 20 here, minus 1 plus 2. Okay? So 1 over V is plus 1 over 20 and V will be equal to plus 20 centimeter. Plus 20. I am getting my answer with proper optical sign convention. Plus 20. What is the meaning of plus? That means it is to the right of pole. Okay. That means I will get my image somewhere here. I will get my image somewhere here. I got one answer. What kind of image it is going to be? Is it real or virtual? Okay. Is it real or virtual? What do you think? Virtual. How do I know? Because this is a mirror. It is a mirror. In a mirror, image forms because of reflected light. The reflected light, the light is going towards right, the light will be reflected towards left. So if they have a chance of meeting, if they actually meet, then they can meet only on the same side. They cannot meet on the other side. That is physically impossible. For that to happen, the light has to penetrate through this mirror. And if the light penetrates, it is not mirror. The job of mirror is to reflect, to send back the light. Light is going towards right, it has to come back, reflected back to the left. A real image forms when reflected light meet. Reflected light can meet only to the left, they cannot meet to the right. That means this is going to be a virtual image. A virtual image. What will be distance? Okay, this distance is 10 centimeter. Okay, this distance is going to be 20 centimeters. 20 centimeter. Now, the ray diagram, corresponding ray diagram. Okay. To find the image, I need minimum 2 light ray. Let me take one simple, this is the simplest one. I take one light which goes along the principal axis. It hits the pole, okay? It will be reflected in this direction. So this becomes one reflected light. Reflected light. If you take any other light, okay, it is going to be reflected, appearing from this point here. That's how it is going to be reflected. Okay, so this is going to be by angle of incidence. Understand this very, very well. This is going to be by angle of incidence here, I. Okay, light will be reflected like this. This is the first reflected light. This is R1. Second reflected light. This is angle of incidence, angle of reflection. This is theta. This also is going to be theta. Okay, and when I extend these two lights, okay, they are going to be, they appear to be coming from this point here. This becomes my image. But this is not a real image. This is a virtual image. If I keep a screen here, I will get nothing. I go behind the mirror, I see nothing. I see this image only as long as I am in front of mirror, from here. Okay, you understand this? Okay, now the second one, 30 centimeter. I'm going to clean this. Okay? Now the second one is 30 centimeter. Let's see where do I get the image. Second is 30 centimeter. Okay. The object is kept where? To the front of mirror or on the other side? It's a real object. It has to be kept in front of mirror. You want to see your image, you have to be in front of the mirror. If you go behind it, you cannot see your image. There is no image in that case. So this is my mirror, principal axis, pole, this is focus, this is center, this is 20, object is somewhere here, this is my object O. Okay, this distance, the distance here is 30 centimeter. 30 centimeter. What will be image? 1 over V is equal to 1 over F minus 1 over U. What is F? Minus 20 minus 1 over minus 30. Okay, so this becomes minus 1 over 20 plus 1 over 30. This is 60 minus 3 plus 2. Okay, what do I get? 1 over V is equal to minus 1 over 60. V is minus 60 centimeter. Minus. I'm getting a minus. What is the meaning of minus here? Okay, distances to the right of pole positive, to the left of pole negative. Negative means it is to the left of pole. So my image is somewhere here. This is my image. This is my image. Okay, this distance is going to be 60 centimeter. Image. What kind of image? Real or virtual? Okay. This image is formed on the side where reflected rays are present. Okay. The reflected rays are coming back on the same side, on the left side. On the same side, I am getting the image. That means the reflected rays are actually meeting there. This becomes a real image. Now, what about the size of object? Okay, so this thing you have to remember. For a point object, its height is 0. Height is 0. Height of image will also be 0. Point object, point image. Ray diagram. Let's take one standard ray here, which goes towards the mirror along principal axis, hits the pole, and it retraces. This becomes my one. This is my one reflected ray. It is coming back like this. Okay, so this becomes one reflected ray. I need minimum 2. Okay, let me take one general ray here. Let's say this is my general light ray. At this point, what is angle of incidence? This is the angle of incidence. Look at this. This is angle of incidence. Light will be reflected. Okay, angle of reflection will be same. This becomes angle of reflection. This will be the second reflected ray. Both are meeting. Both are actually meeting here. Okay, and that's how my image becomes real. Okay, now a very interesting thing. When you solve this one, 60 centimeter. So what we get? We get virtual image in the first case, real image in this case. In both cases, my object is real. Okay. Now, if I solve the second case, object distance is 60 centimeter. Let's see, we are going to get one very interesting answer. 1 over v is equal to 1 over minus 20 minus 1 over minus 60 minus 1 over 20 plus 1 over 60. This is 60 minus 3 plus 1. 1 over v is minus 2 over 60 minus 1 over 30. V is minus 30 centimeter. When object distance is 30, image distance is 60. Object distance is 30, image distance is 60. We can interchange it. If I make this my object, if I keep my object here where the image was formed, then my image will be at a point where the object was kept initially. Okay, so when my object distance becomes 60, image distance will become 30. Object and image can be interchanged. They can be interchanged. Okay, how this becomes possible? Because of reciprocity. Instead of I can reverse all these light rays. Okay, if I send my light ray in this direction, okay, then it will be reflected in this direction here. This becomes my reflected ray. Here also, this is my object. Okay, this becomes my incident light. Okay, so this becomes my reflected light. Both these lights are meeting here. I am getting a real image. This is going to be a real image. So remember this, object and images can be interchanged. Also, we are doing it for a concave mirror. I am getting both type of images, real as well as virtual, both. Now let's do the same thing for this convex mirror. Okay, convex mirror. Same thing for convex mirror. Okay, same thing for convex mirror of same radius. Convex mirror. Now I have a convex mirror. Okay. Okay, so let's complete this. Then next class we are going to do more problems. Now we just have to do problems. Okay, only problems. Now I have a convex mirror like this. This is my center. This is my focus. Okay, this is the convex mirror. My object is kept somewhere here. This is my object. It is kept at a distance of 10 centimeter. Okay, or let's say it is here. Object. Okay, this is 10 centimeter. Where will be image? Okay. Now for this mirror, what is going to be focal length? Focal length is going to be equal to plus 10 centimeter. plus not 10 but plus 20 centimeter. The magnitude is 20. When I use the sign convention, it is going to be plus 20 or minus 20. Okay. So this is my object. The light rays are going in this direction. Light rays are going towards right. So the distances to the right of pole, distances to the right of pole become positive, to the left it becomes negative. Focus is to the right of pole. Incident rays are going towards right. Distances to the right of pole are positive. So focal length will be positive. The radius will be positive. That's why I am writing focal length plus 20. What will be object distance? Object is to the left of pole, which becomes minus 10 centimeter. Where is the image? So 1 over plus 20 minus 1 over minus 10. 1 over 20 plus 1 over 10. This is plus 3 over 20. Okay. Image distance is plus 20 over 3 centimeter. 6.67 centimeter. This is 20. I am going to get an image somewhere here. This is 20. Half will be 10. Okay, it will be 4 half. This is going to be my image. Now, what kind of image? Is it real or virtual? Okay. If I have a real image, it can only form to the left of this side. Only on the reflecting side. This is a case of mirror. Mirrors reflect light. Whatever light is incident, they are going to reflect it backward. Okay. So if the reflected light meet, they can only meet where they are reflected. Okay. That means to the left of this here. Image, I am getting an image on the other side. It must be virtual image. There is no other possibility. Now, how do I draw? And size, point object, point image. No doubt about it. Size of object is 0, size of image is going to be 0. Okay. Now, if I take one light here, it is going to be reflected back along the same path. It is going to retrace. This becomes my one reflected light, R1. Here, now, what will be angle of incidence? This is the angle of incidence. This is the angle of incidence. Angle of reflection is going to be same. Light will be reflected like this. This is R2. Okay. R1 and R2, they are not actually meeting. Okay. They appear to be meeting here at this point. That becomes my virtual image. Okay. Now, second case, 30 centimeter. Okay. Second case. F is plus 20 centimeter. U is minus 30 centimeter. What is 1 over V? 1 over 20 minus 1 over minus 30. Okay. So this becomes 63 plus 2. Okay. So V is plus 12 centimeter. Plus 12. This was 6.6. 6.6. What about this? I am getting here at a distance of plus 12. So this is my focus. This is my center. My object is kept here at a distance of 30 centimeter. This is my object. This is 30 centimeter. I am going to get an image somewhere here. This is my image. This is 12 centimeter. Okay. The light will be reflected like this. Okay. This is how the light is going to be reflected. Okay. Object is moving away from mirror. We are at the same time we are discussing many properties also. Those properties you have to keep in mind. When the object is moving away from the mirror, the image is moving towards focus. Earlier it was 6.6, now it is 12. Object is moving away from focus, away from the mirror. The image is moving towards focus. Okay. Let's see. Let's do it for the other case. U is minus 60. Okay. So F is minus 20 plus 20 centimeter, and V is minus 60 centimeter. Let's see what we get. Okay. No, U. So 1 over V is 1 over 20 plus 20 minus 1 over minus 60. This is 60 here, this is 3 plus 1. Okay, so 1 over V. So this V becomes plus 15 centimeter. Plus 15. Again, it is moving towards the focus. This is my focus here. This is focus here. This is center. Okay, my object is kept here, somewhere here. This is my object. Okay, this is my object. Object distance is 60 centimeter. I am getting an image here. This is 15 centimeter. Okay, the light ray is going to be reflected like this. What do we conclude? As the object moves away from the mirror, image is shifting towards focus. And when the object is at a very large distance, it goes to infinity. Where is the image? At focus. Okay, these things you have to keep in mind. Okay, that's it. In this class we used how to apply sign convention, how to apply mirror formula. Okay, next class we are going to do more problems.